Hey everyone! Today I'm diving into the world of statistics to unravel the mystery of factorial analysis of variance, or ANOVA. Sounds complicated? Don't worry, I've got you covered. So, what is factorial ANOVA? At its core, it's a way to compare means across multiple groups. Imagine you're a researcher studying how different teaching methods and student backgrounds affect test score. You have two factors: teaching methods and student backgrounds. Factorial ANOVA helps you understand not just the individual impact of each factor, but also their interaction effects. Think of it like this. You're baking cookies and experimenting with different ingredients and oven temperatures. Factorial ANOVA tells you how each ingredient affects the cookies and how changing the temperature interacts with those ingredients. Now let's break down the key components. We've got factors, levels, and interactions. Factors are the independent variables like teaching methods and student backgrounds. Levels are the different categories within those factors, such as traditional versus modern teaching methods. Interactions show how the levels of one factor affect the levels of another. To perform a factorial ANOVA, you start with your hypotheses. The null hypothesis states there's no effect, and the alternative hypothesis suggests there is an effect. You will calculate F values to determine if the observed variances between groups are significant. If the F value is high, it means there's a significant difference, leading you to reject the null hypothesis. But remember, factorial ANOVA isn't just about numbers. It's about understanding complex relationships in your data. It helps you make informed decisions and draw meaningful conclusions from your research. And there you have it. A quick dive into factorial ANOVA. Keep exploring, keep questioning, and most importantly, keep learning. Thanks for watching. Don't forget to like, subscribe, and hit the bell for more insightful videos. See you next time.